In this video, we're going to talk about getting from names to formulas, to structures. Okay, so we're going to look at some examples we haven't seen in previous videos and try to analyze them and kind of pick apart these names to help us to be able to derive a structure from that. Let's start off easy. Let's look at 2-methyl-1-butene. 2-methyl-1-butene. My pen seems to not want to behave correctly. There we go. All right, 2-methyl-1-butene. So let's pick apart this. Name and see what we can get here. Ene. All right, so we have a double bond somewhere. But, we have 4 carbons, and the 1 is the number carbon where the double bond is. We have a methyl group. All right, methyl is the CH3 group, and it is on number 2. All right, well, butene, 4 C's. Let's draw 4 C's in a row. All right, so there's our 4 C's. Now we have a double bond off of 1. So at this point we can label these. I'm going to do this fairly faintly. 1, 2, 3, and 4. Okay, so off of the 1 we have a double bond. So let's put a double bond there. All right, so there's our double bond off the 1. Now off the 2 we have a methyl group. All right, so there we go. We have all of that now. 2-methyl-1-butene. Now you might be saying, well, Doc Haney, I thought you said in another video we don't need to put this one here, and we don't. It's understood, but it doesn't hurt to have it there. You're not going to lose points for being meticulous. You're not advanced chemists, and you don't know sometimes when the one is understood and you need it in there or not. So always err on the side of caution. All right, what are we missing here? Well, we're missing some hydrogens. Each carbon has 4 bonding centers. Let's see, this carbon on number 2, 1, 2, 3, 4, it's already done. And this first carbon needs its H's. So we should be able to go around and take a look here. Oh wait, I think I made a mistake, didn't I? Do you see it? Let's look first. This carbon, 1, 2, 3, 4. This carbon, 1, 2, 3, 4. This carbon, 1, 2, 3, 4. And this carbon, 1, 2, 3, 4, 5. Ah, there's my mistake. There's my mistake. Hope you caught it. So every carbon has 4 bonding centers, and we now have 2-methyl-1-butene up there, or 2-methyl-butene. All right, let's take a look at another name. This one a lot more involved. All right, cis 2,3 dichloro 2-heptene. All right, cis 2,3 dichloro 2-heptene. All right, well, let's break this apart. Ene, double bond. And this 2 is referring to, it's a double bond on number 2. Hept, we have 7 carbons here. Dichloro, we're going to have 2 chlorines. All right, that looks like a 5, so let me erase that. 2 chlorines, and they're on numbers 2 and 3 carbon. And the cis. All right, cis is a term used for double bonds when you have substituents on either side of the double bond. Cis means they're on the same side. The opposite would be trans, we're on the opposite sides. And you probably don't realize it, but trans fats refer to this trans shape because if you know anything about fats, saturated fats, meaning they all have single bonds between the carbons, are the artery clogging ones. The really bad for you fat in high quantities. Pardon me. But unsaturated fats, when you put a double bond in, are better for you. These are less artery clogging fats. However, if they have the trans formation, trans fats, hence the term, they have the same molecular shape as if they were all saturated fat. And that's why trans unsaturated fats are bad for you. Even though they have the double bonds, your body can't tell them apart from saturated fats because they are the same shape. They have the trans conformation. But we're talking about cis here, so things are going to be on the same side. So let's start off. Hept, 7 C's, 3, 4, 5, 6, and 7. I'm going to scroll down just a little bit, give myself a little bit more room, but not lose some of the information here that we have. I can just get, there we go. Now, all right, so there's our 7 C's. We got that done. We have a double bond on number 2. That's done. And let's just name, or let's just number these. 1, 2, 3, 4, 5, 6, 7. All right, we have 2 chlorine atoms off of 2 and 3. Okay, and we want them both on the same side because we're cis. All right, is that it? I think that might be it. Okay, well now let's rewrite this so we can see this cis in a better light. Because remember, when you have a double bond here, remember from week 2, it's a trigonal planar shape. Okay, so this is how it's actually going to look in real life, not this straight business, but it's in fact going to have these 120 degrees here. It's cis, so the chlorines will be on the same side, as will the carbons. So we have then 1, 2, 3, 4 carbons after this. CH2, 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 and then CH3. All right, am I missing anything here? 1, 2, 3, 4, 5, 6, 7. So we have the heptene, double bonds on 2, cis arrangement, chlorines are on the same side, the chains on the same side, and the chloros are off 2 and 3. So this is it. This is exactly what the name gave us. Let's look at 2 more examples. All right, how about 2,4,6 trimethylphenol? 2,4,6 trimethylphenol. All right, well, looking at this, we see the all. Obviously, it's going to be an alcohol. But we have the fen. Fen. What does that pertain to? Oh, right. Benzene with a particular group on it gets special names. And in this case, phenol refers to a benzene ring with an alcohol on it. So I'm going to write this in both ways that we can write a benzene ring. Circle, or the 6-membered ring with the alternating double bonds. Okay. Now, let's put the OH at top. And since that dictates all of the numbers, that's going to be 1. I'm going to label all these carbons on both forms of writing benzene. Now, going back to green, we have trimethyl. Remember, methyl is CH3. We have 3 of them, and they're on 2, 4, and 6. 2, 4, and 6. 2, 4, and 6. So we could leave it like this, like a skeletal structural, or if we want, we can just add the CH3s here. It doesn't really matter. I'll leave this one a skeletal structure. All right, so do we have everything? We have phenol, right? An alcohol with benzene. We have 3 methyl groups, and they're on 2, 4, and 6. Very good. Finally, let's do one more example. All right, this one is going to be 3,4-diethylcyclopentanol. Okay. That's a mouthful. 3,4 dimethyl cyclopentanol. Okay, let's break this down. We see the all again. Got to be an alcohol. Pentane, 5 C's, and single bonds. Cyclo, we're going to have a ring of these 5 carbon single bonds. Dimethyl, we're going to have 2 CH3s, one off of number 3 and one off of number 4. So let's do our 5-membered ring. All right, and wherever we're going to put this, oxygen, or the alcohol, is going to be the 1 carbon. Let me move this up a little bit so I have room. Let's put it at the bottom, OH. All right, so that's going to require all of the others to be fully numbered now. 1, 2, 3, 4, 5. Okay, going back to green. All right, so we got the alcohol, we got the 5 carbons in a ring. Now we just need these 2 methyl groups off 3 and 4. Okay, all right, and there we go. We have everything we need there. So these are just some examples of some other things you'll see, and kind of the rationale behind them.